Hi, and thanks for visiting my channel. This video introduces all the Di-Acro 17-ton by 48-inch press brake content and provides some background on the material. Note there is a link in the description to a press brake content index. Material includes videos, drawings, spreadsheets, and textual content. As for the videos, I have organized all the press brake videos in their own playlist. The entire collection can be played, or choose selected videos that interest you. I have this machine in my shop and it generally works well for the bending I do with mostly 50-52, .063 inch, .090 inch, and .125 inch thick aluminum. That said, I have struggled with certain aspects of its operation trying to make accurate bends, the back gauge being perhaps the most problematic. A DRO can be installed, which really helps setting the back gauge. A video covering this project is available. The time invested in the upgrade is well worth the benefits. My approach doesn't alter the machine in any way by making use of retrofit brackets. The DRO won't solve wear problems with the back gauge design, however. My back gauge, owing to wear, has some front to back slop which interferes with setting up accurate bends. I found putting a slight preload on the vertical guides, pushing them away from each other, removes this slop. You can do this by loosening the bolts on the horizontal bar, creating a preload, then tightening the bolts. Too much preload will make the back gauge tight to adjust. Use just enough to remove front to back slop. If the back gauge wiggles around, you'll never get reliable bend accuracy. There are some tricks shown on how to align the upper and lower dies and check that alignment under the pressure of a bend. If your dies aren't aligned, bends won't be as expected. I work with simple straight 90-degree V-forming dies, and the videos are slanted towards that tooling. There is text on the deep dive with algebra and geometry to develop formulas for bending, allowances, and K-factor. Spreadsheets have been created to input drawing dimensions for a finished part, then use the formulas to provide flat layout dimensions and back gauge settings. The machinery's handbook has good bend allowance tables for common metals, which I've used successfully. There is a video on explaining K-factor and how it relates to bend allowance if you need help understanding them. Some solid modeling programs use the K-factor for their sheet metal functions. If you're bending metal, you'll need a bend allowance. There are 3 videos showing how to make a project box, TIG welded pan, and bending an accurate U-channel. There is another video on figuring how deep a U-channel can be bent before it hits the die or ram faces. The entire collection should help with your projects. Bending metal has its theory, but also an empirical side. The goal here was to present a theory, then take it off the sheet and check it with making actual bends. Thanks again for visiting. I hope you enjoy the content and find it helpful with your press brake and projects.